Many doctors recommend artificial sweetener to their diabetic patients. Idea is artificial sweeteners provide sweet taste without affecting blood glucose levels. Most commonly used artificial sweeteners are aspartame, saccharin, sucralose, asulfame, potassium, and neotame. But how safe these artificial sweeteners are for diabetic patients? Are they good? Are they bad? Let's take a look into this today. Our first study is a systematic review of metabolic effects of artificial sweeteners in youth. They looked at 18 human studies and they found out that few small randomized controlled trials conducted in children did not find an association between artificial sweetener consumption and weight change. Means artificial sweeteners neither made kids gain weight or lose weight. But drawback of these studies was that they were not specially designed to look for the effects of artificial sweeteners on weight change and presumably not designed to find such kind of effects. Artificial sweeteners are also called NAS. NAS stands for non-caloric artificial sweeteners. Our next study looks at the effect of artificial sweeteners on the gut microbiome. Gut microbiome simply means bacteria, mostly good bacteria that live in our digestive pipes. This study was published in 2015. They acknowledge that research about artificial sweeteners is so conflicting. Some examples of non-favorable studies are Sweeteners and colleagues, who demonstrated weight gain in rats following consumption of saccharin, asulfame, potassium, or stevia. Saccharin was also linked to increased adiposity. Adiposity means storage of fat. Basically, these artificial sweeteners increase the fat storage in the mice. Many other studies found this side effect of artificial sweeteners causing weight gain in mice. Aspartame is world's most common artificial sweetener. It was also found to induce hyperinsulinemia and impaired insulin tolerance. Hyperinsulinemia means excess levels of circulating insulin in comparison to blood glucose. And we learned in the previous video that hyperinsulinemia causes insulin resistance in the body and is bad for diabetic person. On the other hand, Flat and colleagues described anti-hyperglycemic and anti-hyperinsulinemic effects of saccharin in genetically obese mice, coupled with attenuation of weight gain. Means saccharin lowered high levels of circulating insulin and did not raise blood glucose. Also, it stopped weight gain in mice. Some studies showed positive and negative effects at the same time. For example, Shibata and colleagues described anti-hyperglycemic effects of saccharin in mice that also featured increased adiposity and hyperinsulinemia. Now we have an idea how complex the research is at the moment about artificial sweeteners' effect on blood glucose. There is no definite conclusion at the moment whether artificial sweeteners are good or bad. So after considering all this information, researchers in this study they concluded that at the start of their study they observed that high dose administration of three different sweeteners to mice induced a disturbance in glucose homeostasis, means they disturbed regulation of blood glucose levels. They then they focused on saccharin and they demonstrated that saccharin induced glucose intolerance by affecting gut microbiome composition and function. So they concluded that it appears artificial sweeteners affects blood glucose of mice in a negative manner, but the full extent to which NAS may affect the human microbiome and consequently human health require further studies in form of prospective blinded clinical trials. Our next study we will look at is a systematic review. In this review, they looked at the effect of artificial sweeteners on glucose metabolism and appetite regulating hormones. They tried to review 14 human observational studies, but they concluded that effect of artificial sweeteners on glucose metabolism are not clear. Again, similar thing was discussed in our previous study that more research need to be done as control trial to see the effect of these artificial sweeteners on human health. Our next study looks at how natural and artificial sweeteners and high-fat diet changes differential taste receptors, insulin and TLR4 mediated inflammatory pathways in fat tissue of rats. TLR4 stand for toll-like receptor protein. Their activation in the body produces inflammatory molecules like cytokines. This study was a very complex study, and in this study, they found out that sucrose is simply your normal table sugar, or sucralose, which is an artificial sweetener, they both caused hyperinsulinemia. When either one of them was combined with high fat diet, it led to hyperglycemia as well. So, in theory, if we extrapolate these results to humans, we can say that high fat diet combined with sugar and artificial sweetener can cause insulin resistance and raise blood glucose. But it's a little bit extreme to extrapolate these results directly to humans, as we know there are differences in the metabolism of a human and metabolism of rats. But again, this should raise some alarm bells in our head regarding the use of artificial sweeteners, sugar, and high fat in our modern diet. Our next study looks at the effect of aspartame, which is one of the most commonly used artificial sweeteners today. It looks at the effect of artificial sweetener on the liver and kidney tissues. In these experiments, female rats were fed normally, and then one group had normal drinking water, and other group had aspartame in the drinking water at the dose of 500 milligram per kilogram of body weight for 1 month. After that, they killed the mice and studied liver and kidney samples. Mice that were fed aspartame water, their liver tissue showed degradation and change in structure of liver cells, and their liver cells showed signs of cellular death, necrosis. In addition, there were many other negative effects. Even if some of us don't understand terminology, it's obvious that aspartame had loads of bad effect in the liver tissue. Similarly, kidney tissue was in a bad state as well. Collapse of the renal cavity, of the renal glands, the appearance of bleeding and narrowing inside the glomerular cavity and in the walls of renal tubules, and congestion of blood, which led to emergence areas of extensive destruction and visible bleeding in some areas of renal tissue. After everything we learned about artificial sweeteners today, we know that science says that artificial sweeteners, the way they are processed in human body, is different to the way they are processed in a rat's body. But again, would you put something in your body that has been proven to cause detrimental effects in animals? Are we that desperate to have something sweet or something sugar, just to find out that 20 years down the line government might say, oh yeah, sorry, artificial sweeteners are actually causing liver damage, kidney damage, diabetes, and actually cancer in humans as well. So is it really worth it? So we just need to make a stand on this. Research, there's lot of research that need to be done on humans. There are not very many, well, in fact I would say there are none clinically reliable controlled trials in humans who are using artificial sweeteners. So first of all, there's a lack of data on the safety of artificial sweeteners, and they are proven to cause detrimental effects in animals. These two factors should automatically stop us from artificial sweeteners. And in fact, we need to reduce our sugar intake as well. If we feel that desperate to have something sweet, can we say that we are addicted to sugar? So today my recommendation is try to cut out artificial sweeteners from your diet completely as much as you can. Minimize your sugar intake or even stop it. We don't need to be addicted to sugar. And high fat diet is proven again and again to cause insulin resistance. So if we eliminate these three factors, I think controlling our type 2 diabetes could be a little bit more easier. Thank you.